Hey guys, how's it going? Welcome to another LeetCode programming video tutorial. Today we are going to solve problem number 17, letter combinations of a phone number. And just FYI, this is also one of the most asked questions in Amazon interview. The question stem says, given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. And they also have a mapping of the digits and the characters over here, and probably this is Nokia 3310. Do let me know in comments whether do you think whether it's the same phone or not, and if you have the same phone, then also let me know why. But anyways, coming back to the question, what this means is if we have say an input of 23, what they want is they want all the combinations of each and every character that those numbers could represent. So over here, the number 2 represents A, B, and C. So we want to combine each and every character in the number A, B, and C with each and every character in the digits after that. So over here, we only have like two digits, 3. So we're going to combine A with D, A with E, A with F. So that's how this first three are formed. Then what we're going to do is we're going to combine B with E, B with D, B with F, and so on. Now, before jumping into the code, let us just try to whiteboard the solution. Just try to think through how this could be solved. So what we have over here is we have this table, and it is the same representation that we saw in that image. The numbers are from 2 to 9, and each and every number represent certain characters. We also have an input and the expected output. Now, what we do in order to get this is we start looping from left to right over each and every digit in the input string. So when we start looping, initially we get 2. And if you have been following my video series, then a couple of days back I created a video for creating a binary tree in which I briefly explained what DFS looks like. So we are going to solve this using a similar method called backtracking, but then there are a lot of concepts of DFS which are handy because this to me at least it looks like a tree, and we are just gonna explore all the nodes that can be formed by each and every digit that we see in the input string. So let's see. So we start from left to right. So we have number 2. From number 2, what do we do? So we ask the table, hey table, like what are all the characters that number 2 represents? And it returns us the list A, B, and C. So what do we do? We take each and every character, and then we need to loop over each and every digit that are after the current number. So currently we are on 2. So we're going to go to 3. We are going to keep A in our in a temporary variable. And what we are going to do is we are going to take 3 and we are going to ask the table like what are all the characters does 3 represent. So we are going to get D, E, and F. Now when we get D, E, and F, we are going to concate A with each and every character. Now in our example, we don't have any more input digits. Had we had like say 5 or 6 or 4, then we would have to again go back to the table and ask like what do those numbers represent, and this tree would have continued. Now since we don't have that, what we're going to do is when we reach the end of the input string for this path of the tree, we're just going to add this string the string variables that we have into an output list. So this marks the end of this path. Now if we backtrack from over here, now we're going to reach, when we backtrack to 2, we had just explored the path that was starting with A. Now we are going to explore the path that is starting with B. So from B we again take 3. At 3 we again ask the table like what do 3 represent, so we get D, E, and F. So we concate each and every character, and since this is AND, so we add them to the output and we go back, and then we reach C. from C, we again take the next character, so that is 3, and so on. I know this might have sounded complicated, but the code is pretty straightforward. So let's try to walk through the code, and maybe this is the first time you are solving a problem with using backtracking. Awesome. So the first thing that we do over here is we create this table that is nothing but a hash map or a dictionary, which has this key value pair. The next thing that we do is we need to, so I have hidden this private function that I have created so that it does not distract us right now. What I also have over here is I have created an output list, and eventually this is the output list that is going to be returned. Now what we want to do is we want to call a function which takes two parameters. The first is the string, and this is the temporary string which will hold the values of each and every character. And the second is the digits, and digit is nothing but the input. So how does this work? This is a recursive function, and anytime we have a recursive function, we must always think about the end condition. So if you remember, then in our example, when we reach the end of the string, so after 3, we would have no, we would be left with no digits. So that is the time when we would take the, that is the time when we would take these variables or these strings that are formed and add it to the output string. So that's what we are going to do, and that forms the exit strategy for our recursive function. When the length of the digits is equal to 0, and if we have string, so this is not a null character, so what do? We just append it to output the output list, and this is the output list that is eventually going to be returned. So this forms the straightforward exit strategy. And how does the function work? So we are gonna loop over each and every character for the first digit in the digit string. So if we are given, say, string 2 and 3, then what we are going to do is we are going to loop over each and every character that are there in the first digits, only in 2. So in this case, the 2 would represent A, B, and C. So we're going to loop over each and every one of them. And for each and every character, what we are just going to add it, so concat it to the current string. So initially we're just starting with an empty string. So the first time this would become just A, and then we are taking the substring or the sub array of this input digits, because that's what we are passing. So what we are going to pass the next time, we are just going to pass 3, because that is the we're going to pass from over here. So in the next iteration, what we are going to get over here is it will not hit this exit condition, it will reach over here, and what it will see is, okay, so I need to loop over each and every character in the digit 0. So digit 0 will hold 3, so it will ask the table, what do I do? So it will say D, E, and F. So first it will take D, and so we already have A over here, so it will be like A plus D, and this digits 1 comma 0 so would be an empty list, because right now we only have 3 in our digits. So when we try to take substring of it, it will be just an empty list. So since we have an empty list, we'll do a one more recursive call, but then in the next recursive call, we are going to hit this exit strategy. So it is going to see that, hey, the length of the digits is 0. It will have some value in S. It will have A and D. So it will just append A and D in it, and it will return. At that time, it will continue forward. So A with E, and then A with F, and so on. So that's how and that's how it will work for the rest of the characters as well. um, let's try to submit this just to see if it works. Keeping fingers crossed. Oh, okay, that's good. And alrighty, this is taking some time. Never mind. So perfect. So it is accepted. It is an accepted solution, and this should work. So what should be the runtime of this solution? Well, we are looping over each and every character for each and every digit. So given that most of the numbers have three characters in them, so we will and there are, let's say there are n digits, so we are going to loop over 3 raised to n times, and two of them, 7 and 9, they have four characters, so for them we are going to loop 4 raised to n times. So the runtime complexity of this solution is going to be 3 into n, 3 raised to n cross 4 raised to n, and so will be the space time complexity. And just as a thumb rule, in most of the backtracking solutions, the runtime is always exponential. It is mostly 2 raised to n. Of course, there are like exceptions when we have some sort of memoization, and we have some sort of matrix or dictionary in which we are just saving variables, and then we would be able to reduce the runtime. But we have not done anything like that in this solution, so it's still like 3 raised to n into 4 raised to n. So do let me know how you found the video. Comment and let me know if there are other questions that you would like me to solve. If you like these videos, please do subscribe. Next, I'm going to solve word search and word break, which are also one of the most asked questions in Amazon. So if you would like to be notified, then please do subscribe. Until then, have a good day. Bye bye.